Assalamualaikum and hi everyone. Today we are from group 14. We'll discuss about the first row transition elements for their oxides and hydroxides. In this video, we will talk about the introduction of first row transition elements, and then their oxides and hydroxide, and lastly about the applications of the first row transitions elements. Let's begin with introduction. So basically, first row transition element is D block element, and they have metallic behavior, but across the period, the characteristic of the metallic decrease. Furthermore, first row transition element have bright color due to the internal transition of DD orbital, and then first row transition element also have more than one oxidation state. Next, their oxides play major role in catalysis, metallurgy, batteries, and magnet. 3D transition metal also display chemical behavior by their partially filled d orbital. Lastly, first row transition metal form core of many important chemical reaction in industry and nature.
The early transition metals such as scandium and titanium are relatively electropositive. Scandium mainly forms scandium oxides, where it exists almost exclusively in +3 oxidation state. This oxide is white solid, insoluble in water, but soluble in dilute acids. Titanium commonly forms titanium oxide with titanium in the +4 oxidation state. Titanium dioxide is a high melting stable oxide and is widely used as a white pigment. Vanadium forms stable oxides in several oxidation states. One important oxide is vanadium oxide, which is formed when vanadium reacts with oxygen. These oxides are generally high melting solids and only slightly soluble in water. Chromium forms chromium oxide, a strongly oxidizing oxide. Its structure consists of chains of tetrahedral, and it is commonly used in oxidation reactions in laboratories and industry. Iron forms several oxides, including iron 2 oxide, iron 3 oxide, and iron 4 oxide. Iron 4 oxide has a mixed oxidation state and a spinel structure, which gives it magnetic properties. Manganese forms many oxides in different oxidation states. The +7 oxidation states form the well-known permanganate ion, which is a very powerful oxidizing agent. Cobalt commonly form cobalt 2 oxide and cobalt 3 oxide. Cobalt 2 oxide behaves as a basic oxide, while cobalt 3 oxides show spinel type behavior. These oxides are usually dark in color and insoluble in water. Nickel mainly forms nickel oxide in the +2 oxidation state. Nickel oxide is a green, high melting solid and is the most stable oxide of nickel. Copper forms two common oxides, copper 2 oxides, which is red, and copper oxide, which is black. Both oxides are insoluble in water, but dissolve in acids. Zinc, although often considered a borderline case, form a single stable oxide, zinc oxide, in the +2 oxidation state. Zinc oxide is white when cold and yellow when hot, and is amphoteric, which are reacting with both acids and bases.
Now, let's move on to their hydroxides. First and foremost, let's we look about the scandium hydroxides. Here are two methods to produce scandium hydroxides. Firstly, the participation of scandium salts. So you react scandium halide with the strong base. You will form the precipitation of scandium hydroxide plus metal halide. Number 2, scandium hydroxide can be prepared by the reaction of scandium metals with water. Scandium will react slowly with water but rapidly if heated. So here are the chemical equation. The scandium react with water will form scandium hydroxide plus hydrogen gas. But remember, scandium hydroxide is an amphoteric compound, which means scandium hydroxide can react with acid and alkali. When scandium hydroxide react with acids, the neutralization process occur, so the salt and the water will form. But when the scandium hydroxide react with alkali, it will form complex compound. For example here, sodium scandium hydroxide. Extra information about the scandium hydroxides. Basically, scandium hydroxide is white in color and also insoluble in water.
For titanium hydroxide is unstable and easily decomposed when heated. Upon heating around 120 to 400 degrees Celsius, it loses water to form titanium dioxide. Titanium dioxide is white solid and widely used as paint pigment, sunscreen, and also food colorant. And also, titanium hydroxide shows amphoteric behavior which react with acid and bases. For vanadium hydroxide, the common oxidation state is +2 and +3, and vanadium hydroxide are generally insoluble in water, and they are also less stable and less common use in industry. And vanadium hydroxide mainly studied for their redox behavior rather than application. For chromium hydroxide, it will form a gray, green or cloudy green precipitate. It is also amphoteric, which is react with acid and bases and dissolve in excess NaOH to form a green complex solution. And chromium commonly exists in +3 oxidation state, which is the most stable for chromium. And chromium basically used in pigments and also cosmetics. For manganese hydroxide, it appears as a white or pale pink solid. It is also sparingly soluble in water and easily oxidized or decomposed to manganese oxides upon heating. And manganese oxide commonly used in battery and wastewater treatment. And the last one for ferrum or iron hydroxide, ferrum hydroxide. It is insoluble in water and commonly appear as a dark orange-brown precipitate. It is also an amphoteric compound and basically used for removal of phosphate in water treatments and also tattooing.
Next, let's talk about the cobalt, nickel, copper and zinc hydroxides. Basically, we combine these four metals due to the preparation of metal hydroxide for these four metals is similar, which is we react the metals with base. For example, cobalt chloride react with sodium hydroxide will form cobalt hydroxide and sodium chloride. For your information, this hydroxide can undergo a few reactions. The first one, metal hydroxide can react with acid and the neutralization reaction will occur. When the metal hydroxide react with acid, that will form salt and also water. Number 2, complex formations. When the metal hydroxide react with any base like ammonia or sodium hydroxide, it will form complex compound. And number 3 is thermal decomposition. When the metal hydroxide undergo thermal decomposition under heat, it will form metal oxide and also water. Next, let's take a look about the physical appearance of these hydroxides. So cobalt hydroxide, they have two types of the hydroxide. The first one is beta cobalt hydroxide, that most stable and have pink color. Number 2, alpha cobalt hydroxide, that less stable and have greenish blue color. And then nickel hydroxide have green in color, copper hydroxide have blue in color, and zinc hydroxide have white in color. Extra information also, this hydroxide is insoluble in water and odorless.
Assalamualaikum and hi everyone. Today we are going to discuss on the uses of transition metals. We have 10 transition metals to be discussed today. Let's go! The first one is scandium. Scandium used in aerospace industry and also mercury vapor discharge lamps. Scandium is added to aluminum alloys to increase strength, reduce weight and improve wearability, making it ideal for aircraft components. The second transition metal is titanium, which is titanium used in aerospace industry, located in engine, also medical for joint replacement. Titanium is corrosion resistant and lightweight, so it integrates well with bone and is safe for long-term implants. Then let's look at vanadium. Vanadium used in high-speed tools and also catalyst production of sulfuric acid. Vanadium increase hardness, wear resistance and heat resistant in steels used for cutting tools. Now it's time for chromium. Chromium used for stainless steel and also ferrochrome steel production. Chromium forms a thin, protective oxide layer that prevents rusting and gives stainless steel so it is corrosion resistant. Now we're going to discuss on the manganese use. So manganese used in alloy for drink cans and also alkaline batteries.
The world you know is changing. Together, we can transform it for the better. While many brands still rely on hazardous chemicals in production, we choose safety for both life and the environment, while maintaining battery life and performance with our unique technology. By building on the Japanese tradition of uncompromising quality control worldwide. Panasonic manganese batteries, protecting your daily life and the environment.
Panasonic.
Now we're going to see on iron. Iron used in alloying of iron and also catalyst in Haber process. Iron will speed up the reaction between nitrogen and hydrogen to form ammonia without being consumed. So the next one is cobalt, which cobalt is used in magnets and also millennia, which is impart a rich blue color to the glass. Cobalt ions will absorb specific wavelengths of light, producing a deep blue color in glass and ceramics. Now we are going to discuss on nickel, which is nickel being used in a corrosion resistant steel alloy and also catalyst for hydrogen gas oxidation. Nickel will facilitate the reaction involving hydrogen, such as in fuel cells or hydrogenation processes, by lowering the activation energy. Let's move on to copper, which is copper being used in flexible wires and also for plumbing. Copper conducts electricity extremely well and it is ductile, making it ideal for wires and also cables. And for the last one, it is zinc. So basically zinc being used for zinc plating and also vulcanization of rubber. That's all from our group. Thank you for watching.